doesn't look like the others, like this. Very simple. The reason it doesn't look like the others is because it needs to have a 1 on the right side. So the first thing I'm going to do is I'm going to divide everything all the way across by 36. That's going to give me a 1 on the right side. So for the x, you have a fraction 9 over 36, which reduces to 1/4. And for the y, it's just 1/36, so that would be written like that, equals 1. Now the equation is written like the one on your formula sheet. It's x minus h squared, h is 0 in this case, over denominator. It's written just like the one on the formula sheet. So now what we can do is we can do whatever it asks us to do. Okay, it's vertical because the denominator is under the y squared. And our values are h and k are both 0. A is 6 and B is 2. So to graph this, we would go up and down 6 from 0, 0, and left and right 2. Since it's vertical, and A is what we would go vertically, and B is what we would do horizontally. Now, if I want you to find the foci, the formula for that on the vertical column of your ellipses is h comma k plus or minus c. Well, we have to know how to find c, and I gave you that information in between the two columns. There's a little blurb in there that says c squared equals a squared minus b squared. So to find c, it's 32. It's 36 minus 4. So c squared is 32. So you simply subtract the denominators to find c squared. And then you have to take the square root of it. And the square root of 32 is 4 root 2. Once you simplify the square root of 32 using your root simplification skills. So now you can answer all the questions about the ellipse. Center, major axis, minor axis, foci, whatever, based on the green highlighted values. Center 0, 0. Foci would be 0, comma, 0 plus or minus 4 root 2. And of course, 0 plus or minus 4 root 2 is just plus or minus 4 root 2. That's where the focal points would be. Major axis 12, minor axis 4. Just putting in the pieces, or just finding the pieces given the equation. Now we're going to get to one where we have to complete the square. Okay, just like we did with a circle. The reason why these might be a little more tricky is that these are going to have leading coefficients. The circles did not have leading coefficients, so I'll talk through one again, making sure that you realize that you've done all the steps in this before. It's just a matter of confidence and recall. Step 1, make my piles. get nice and organized. Just like last week. You did this up on the boards Friday when you were reviewing. Step 2, which was not part of the circles, we have to factor out the leading coefficients in each separate pile. So for the x's, I'm going to take out a 4. Just like that. Just in that pile. And for the y's, I'm going to take out a 9. And the rest of it's just watching. Okay. All of the steps in this you've done before. It's just a matter of putting it together. Now we have to add something in the x parentheses. Half of the b term squared is 4. But it's not really a 4. It's really a 16 because you have to multiply it by that leading coefficient. So out here at the end, you're going to be subtracting a 16. I didn't write it down, but I'll write it down here at the end. For the y's, we're going to add half of the b term squared. Half of 2 is 1. Squared is 1. But it's not really a 1. It's a 9. So out here with the 11, we're going to subtract our 16, and we're going to subtract our 9. Okay? I'll let that soak in. The parentheses will factor into x plus 2 squared. The y's will factor into y minus 1 squared. All that red and green stuff at the end, if you take negative 11 and negative 16 and negative 9, is negative 36. I'm going to move the 36 to the other side. Like so. And then I'm going to do what we did last problem to get that 1 on the right side. I'm going to divide all 3 terms by 36. And then those 2 fractions. The problems will be set up so they work out really nice. Notice how my fractions are very pretty. 436 reduces to 1/9. 936 reduces to 1/4. Like so.